Hi, welcome to Physics Teacher. In this video, I'm going to go over the solution to a grade 10 math contest question. Specifically, this is question 23 from the Cayley contest of 2020. Give it a try, and I'll be right back with the answer. So what we want to do in this problem is take these 9 digits and create a combination that follows these specifications. At least 1 1 before the first 2, at least 1 2 before the first 3, and at least 1 3 before the 4. And also, no digit 2 can be placed next to another one. So how many different possible combinations can we create following these specifications? Well, since we have to start with a 1, because we need at least 1 1 before a 2, then let's start with a 1. But we have 3 1s, so we could just start with a 1, or we can start with 1 1, or we can start with 1 1 1. All of them follow the same rules. And then we would have to place a 2 next, because we have to put a 2 before the 3, and we have to put a 3 before the 4. So we would need a 2 here, a 2 here, and a 2 here. So we have 3 possible ways to start placing these digits. Let's look at the first way. Let's call this case 1. So if we were to start with 1 and 2, then that means we have 7 other locations to place digits. Now let's start by placing the remaining 2's. Now since no digit 2 can be placed next to another digit 2, we cannot place one in this third digit. I could place one here, for example, and here. That's one possibility. Another possibility would be here and here, or like this, or like this. If you were to do all the possibilities and count up all the different possibilities, you would realize that there is, or you would count, a total number of 10 possibilities. So we have 10 different combinations for where we could place those remaining 2's. Let's just leave that one for now. Now notice we have 5 other places to put digits. Let's place those remaining 2 1's that are left over that we have to place. Now I could place them here and here. They can go next to each other, or like this, or like this, or like this. Go through and count up all the different combinations you can place them, and you will count a total number of 10 combinations that you can place them. Next, we have to place the 2 3's and the 4. Now since we have to place a 3 before the 4, we have to start with the 3. And then there's only 2 possibilities we can do. We can do a 3 4, or we can do a 4 3. So 2 other possibilities. So this leads us with a total of 200 different possible ways to arrange this first case. Let's look at the second case. And we're going to follow it the same way, except now we have 6 other digits that we need to place. And we're going to start with those 2's again, because this last rule is really helpful for us. Now we can't place one here, because we can't have 2 2's next to each other. So we could place one here and here. And again, or we could place it like this, or like this. And you can keep testing different possibilities and count them all, and you'll realize that you have a total number of 6 different positions where you can place those 2's. Alright, so now we have 1 2 3 4 left. So let's place that remaining 1. There's only one left, and there's 4 possible places where we can put it. So that's 4 possible options. Let's put it here for now. So now we have 3 remaining digits to place. Just as before, The 3 must come before the 4, so we have to put the 3 here, and then we'll have 2 other options left, either a 3-4 or a 4-3. So that's another 2 options there. So in case 2, we have a total number of 48 possible integers we can create, or combinations we can create. In our last example, case 3, we have to place another 5 digits. Let's again start with those 2's, so we can't put one here, but we can put one here and here. Or like this, or like this. So there's only 3 possible places. So only 3 possibilities for the number 2. There's no more 1's that can be placed. We've used them all already. And so we're just left with the 2 3's and the 4, which have to be placed like this, either 3-3-4 or 3-4-3. So that's a total number of 2 combinations, or for a total of 6 for our case 3. If we were to add up all of our possible cases, we have 200 plus 48 plus 6, or 254 possible combinations. Our answer is C.